Okay, so the difference between 7.1 through 7.5 and 7.6 really is that you're solving equations. So we went through all those other sections. We were really simplifying or evaluating. Now you're going to be having an equation that you're solving. Some equations, you'll look at it and you go, here's the answer. Other equations, you're going to have to apply one of these strategies or one of the other strategies that I throw at you in this section. There is oftentimes more than one way to do a problem. If there's no work, I'm fine with no work. But if you're sitting there doing multiple steps in your head and not showing that, that's not the same thing. So the first example we have here is no work. I'm fine with you saying, here's the answer, it's a no work answer. E to the x equals 1. We're solving this equation for x. X is equal to 0. There's no work to that. That's the zero power problem. Anything to the power of 0, 1. So I have no problem with you writing x equals 0 with no work on that. The second example, 5 to the power of x is 12. No way. You can't do that in your head. And you can't do it on a calculator without a line in between. So I want to see what's the next line going to be. Now if you look at your strategies here, the first two strategies right here, these two are the definition of a log. Press the button. These four are the properties we learned in the last couple sections before break. Product property, quotient property, power property, change of base property. In this example, number 2, how do we solve for x? What could we do? Change it to logarithmic form. We're in exponential, let's switch it to logarithmic. Log base what? 5 of equals x. Did somebody memorize the base 5s over the break? Somebody should have done it. So what base are we going to have to use? 10. We love base 10. Right, Samana?
Yeah.
Why do we like base 10?
Because it's on the calculator.
On the calculator. Okay? So when we do change a base, we want to go with base 10. So we do common log of 12 over the common log of 5. Your answer needs to be between which two numbers? What does x have to be between? 1 and 2. 5 to the power of 1 is 5. 5 to the power of 2 is 25. So x has to be between 1 and 2.
And also change the base formula, right?
Correct. So this is change of base property to go from log base 5 to 12 to log 12 over log 5. What do we get? 1.544. Now, you can do that in one shot on your calculator if you're doing it correctly. Is anyone not able to get 1.544? It's usually a parenthesis thing. If you can't, raise your hand and I'll talk you through it. Okay? Now, this is we have 2 of these, or we'll have a couple of these, I should say. These are the, when I say the logical conclusion would be, we've done a bunch of these over the course so far. If you have b to the power of x equals b to the power of y, then x and y have to be equal. If the bases are the same, and it's an equation, there's no way x and y could not be the same. Now, is it a mathematical operation that we're applying? No, we're making a logical conclusion here. So if you can get an equation where your bases are the same, and you have variables in the power, then the logical conclusion would be that the powers have to be the same. X would have to equal 2x minus 3. Now you're about to an algebra 1 or a pre-algebra type equation that you just need to solve. And x would equal 3, or 3 is equal to x. You can't have the x on the left mathematically, because if you bring the x's this way, it would be negative x equals negative 3. I subtracted x, and I added 3 to get the equation 3 equals x. Does everyone follow that example? If the bases are the same, we have a 7 and a 7. If the bases are the same, then the logical conclusion has to be that your powers have to be the same. If they're not the same base, that doesn't apply. This one's a little bit more complicated, but based on your experience, you should be saying, right, see, I got a 3, and I got a 1/9 as the base over here. We've got a 3 to a power and a 1/9 to a power. Common sense property isn't going to work here. What can you do with the 1/9? How could I deal with the 9? Let's just look at the 9. 3 squared. This is 3 to a power. This could be written as 3 to a power. 3 to the x equals 1/3 squared. The x plus 3. What can I do with 3 squared? What do you mean? Excellent. Invert it, and the 2 becomes a negative. So now we have the same basis, both 3's. On the right-hand side, what can I do with my powers? Multiply them. We have base to a power. 3 to the x equals 3 to the negative 2x minus 6. I'm pretty big on using the parentheses. It's not necessary, but a lot of people who don't use the parentheses, the 6 starts to fall down and become 3 to the negative 2x and then minus 6 after. Be careful with that. What's a logical conclusion here?
X equals negative 2x minus 6.
X equals negative 2x minus 6. In order to solve, what do we do?
So we add the negative 2x to x.
So we get
X.
3x
Oh, yeah.
equals negative 6, and x equals the key here is that all the way back at the beginning, you see this 3 to a power, and you see the 1/9 as being able to be rewritten as 3 to a power. It's all about the same base for this. It's all about getting the same base. Any questions on this example? Try this one. See if you can get the same base. Okay, what base do we want? 4? 2. 4 is easier. 64 is 4 cubed. And 16 is 4 squared. Again, I like to have my powers in parentheses. And as powers of powers, you need to make them higher. Just like with bases, you need to make them lower on the log equations. On the left, it's 4 to the 3x. On the right, 2x plus 2. What's the logical conclusion? 3x equals 2x plus 2, so x equals 2. Now again, why do we put the 3 dots? We put the 3 dots, that means the 3 dots mean therefore. We put them there because it's not a mathematical operation. We didn't cancel the 4's. There's no mathematical way to cancel the bases and all of a sudden you have these floating powers in Halloween music. That's not what's happened. You can't do that mathematically. What we're saying is if the bases are in fact the same, if we do in fact have the same basis, 4s, then the logical conclusion is that the powers must be equal. But it is not a mathematical, I added something, I subtracted, I square rooted, I squared. That's not what we're doing. We're making a conclusion like a geometric proof. Definition of a log, right here. Okay? That's one of your strategies for solving equations. Base to a power equals base to a power. Logical conclusion, the powers are equal. Less often used, but if you have base to a power equals different base to a power and the powers are equal, the logical conclusion is that the bases are equal. So this 2b is less used, but every once in a while that's your get out of jail card. If you can get the exponents to be the same, then the logical conclusion is that the bases are the same. And then similarly, if you have log base b of a and log base b of c, if the bases are the same, what you're taking the log of must be the same. That one will be more prevalent. So 2a and 3 will be very prevalent in solving equations in this section. And when you're really stuck and you got nowhere to go, press the button. Definition of a log. Still waiting for someone to have a really cool, loud one like this. Use the definition of a log. One of my techies, come on. I've seen it on YouTube. You can take this and you can re-record it. And be done. Okay, any questions on these three? Definition of the log on the top, and then logical conclusion properties below. So here's one with logs. Oh, sorry, we're back to exponents. I'm going to show you two ways of this one. So we have this one set up to do twice, because there's two ways. First, the directions are telling you to take the log of each side. My directions are just going to say solve on the quiz or solve on the test. But we're going to show you two different ways to handle these. So the first one, we could do what the direction said. Take the log of each side. Just like adding something or subtracting something, we can say the log of 9 to the x power is equal to the log of 35. Mathematically, perfectly correct, as long as you're doing it to both sides. What are we solving for? X. What do we do next? No.
Log or subtract log.
No. Yeah, we want to drop this x down in front using the power property to get the exponent out of, or the variable out of the exponent position. And now how do I solve for x? Divided by the common log of 9. Log of 35, common log of 35 over the common log of 9. Look at the original problem. 9 to the x is 35. What should your answer be between for x? 1 and 2. 9 to the first is 9. 9 to the second is 81, and 35 is somewhere between 9 and 81. So on your calculator, log of 35, common log of 35, divided by common log of 9, should give you 1.618, according to one member of the studio audience. I love the fact that some of you don't try to do this on your calculator. On the test every year, I have kids who get all wrong answers because they never practice. They don't do their homework, and they don't practice in class to verify they know what they're doing. It takes 3 seconds to do it, but I just am astounded that you will sit there and not try to get this answer, or that you don't even have a scientific calculator with you. That's not good form. Now let me tell you another way to do this. This is logging both sides. Some people like this method. What's another way I could solve 9 to the x equals 35? What else could you do? I'll give you a hint.
That was easy.
Use the definition of a log. If we use the definition of a log, what would we get? Log base 9 of 35. So we've already got x isolated here. And base 9s, Max didn't do it. Ellie, did you do base 9s? What base do you want to use? How come? It's on the calculator. So let's change this to base 10, and we're going to get common log of 35 over common log of 9, which is exactly what we got right here. Is one of these better than the other? Absolutely not. Is one faster than the other? I don't think so. Yeah, I really don't. But you're going to get the same answer either way. And knowing what the answer is going to be in advance is really, really helpful. You should know that x has got to be between 1 and 2. Try this one. Okay? You can do it either way. Doesn't matter. Sorry. Anybody have a problem with coming up with the 1.839? 1.5. Did you have this, log of 27 over log of 6? On your calculator, what's that? Okay, so tell me what you put in your calculator. And it gave you 1.5. You have to be missing a parenthesis. Can I still see it? You put it in. I think something must have happened on the close. Could be. 6 shouldn't matter as much as the 27 close. Okay. Let's try one more just for fun. So see if you can solve this one for F. Jennifer, what'd you do first?
Oh, I subtracted 8.
That's what I would have done too. So 6e to the 0.25x power is equal to 12. On the last quiz, big mistakes here. I'm subtracting 8. I had 4 or 5 people in each class put a 28 here. What the heck? Let's not forget the basics. What do we do now? Now get rid of the 6 so it looks like the last 2 examples. Something to a power equals something. They're in exponential form. That's the way we started in this B problem and in this A problem. We started with something to a power equals something. This one, not so much. But now, we're there. You have a couple of choices on what to do. It's up to you. What do you want to do? The choices are to log both sides or definition of log. Definition of a log. It becomes log base e of equals 0.25x. Log base e is also known as natural log. What's the natural log of 2 equal? .693. Leave it on your calculator without erasing it. So you leave the full number on your calculator because how do we solve for x? Divide by 0.25. And you don't want to use the rounded 0.693. You want to divide the entire natural log of 2 by 0.25. So you're going to get 2.7. All right. Did I go too fast for anyone? Is anyone not getting those numbers? That's the key. Are you pushing and not getting these numbers and you're thinking you should be? Everybody good? If I'm going too fast, you got to help me and put your hand up and say, hey, I know. The second or the third example of a logical conclusion, again, if you can get log base b and log base b and they're equal, the logical conclusion has to be what you're taking the log of has to be equal. Log base 4 on both sides, they're the same. Then the logical conclusion has to be what we're taking the log of, 2x plus 8, has to be equal to 6x minus 12. Now I want to put the bug in your brain right now. You got to check your answers on this. All right, you have to always check them in the original. And you got to remember that when we're taking logs, the log value, what you're taking the log of, has to be positive. So when we solve this, this is easy. 4x is equal to 20, so 5 is equal to x. Now, just because you have a positive value for x doesn't mean it's going to work. And just because you get a negative value doesn't mean it's not going to work. When you plug it in here, you get 18. That's a positive, that's good. When you plug it in here, you also get 18. That's a positive, and that's good. And they're equal, which is even better. So x equals 5 is your answer for this example. These are really nice and simple, easy. We love this stuff. Yes? What would you do here? Yes, you are. You're solving for x. Okay, how would you move 8 over? What would you get? 20. And then what would you do? Well, don't you have to get the x's on the same side? Wouldn't that be a better thing to do first? Which one would you get rid of, 2x or 6x? Which one's smaller? So how do you get rid of 2x? How do you get rid of 2x? When we have 2x plus 8, I want the 2x to disappear. Sure you do. 2x plus 8. If I want to make 2x disappear from that expression, what would you do? I want to get 8. How would I get 8 from this expression? How about subtract 2x? Well, in general, 2x plus 8 minus 2x would leave us with the 8, right? How do you get rid of 2x? You subtract it. How would you get rid of the 6x? You could subtract that. But the general rule is which one's bigger? So get rid of the one that's not. So we subtracted 2x, we got 4x. How do you get rid of minus 12? So that's what I did. I'm just lazy, and I'm not going to show all those steps anymore. If you want to show them, I'm not trying to discourage you. I'm just saying, there you go. And some people will bring the 6x over and the 8 over and then divide by -4 and still get 5. It's okay either way. All right. So here's an example already done for you. Log base 7 and log base 7. So we took what the logs of both sides were what we were taking the log of, set them equal to each other, and got x equals 3. Again, when you plug it back in, 18 minus 16 is 2, and 3 minus 1 is also 2, both positive and both the same. That's a good thing. Try this one. So the logical conclusion again here is that 4x minus 7 equals x plus 5. When we subtract x, we get 3x. When we add 7, you get 12. So x is equal to 4. Again, you might want to check. 16 minus 7 is 9, and 4 plus 5 is 9. Both positive. All good. Okay, so not my word, but I really like it. Solve by exponentiating. This sounds like one of those made-up words from what? Doctor Who? That would be good. I was thinking more that I saw it on a commercial. The guy used to be Doogie Howser. He's on, How I Met Your Mother. And he says, creativity, envision, visitivity. Make up your own words to do whatever it is that you want it to do. How are you going to solve this?
No.
Yes, you are. You're not. Thank you very much, heckler. Use the definition of a log. When you get stuck here, the definition of a log is going to get you out of stuck most often. So when we use the definition of a log, we're going to get 7 squared equals 3x minus 2. 7 squared equals 3x minus 2. What's 7 squared? 49 equals 3x minus 2. 51 is equal to 3x. When you divide by 3, 17 is x. And again, when you check it, 3 times 17 minus 2 is a positive value. That's really critical for us. So when you have a log equation like this, definition of a log will get you out of jail. You'll see in a minute that they won't always look like this. So you might have to do some manipulating to get it to look this way. Everybody good here? Before we go to the next example? Try this one. Solving for x. All right, what do we get for x? 11. 5 squared equals 3x minus 8. So 25 equals 3x minus 8. 3. We good with that? You're close. We need you to be perfect. Where are we missing? Did you have this? Okay. Well, 2.5 and 11, not so much close. Okay. All right. Now, here's where it's going to get tricky, and here's where the extraneous solutions come in, because more often than not, you'll have 2 answers. Sometimes they both work, sometimes one works, sometimes neither works. Check both answers. The positivity or negativity of an answer does not control whether it will work. We have log plus log. What should we do? Multiply what you're taking the log of. It's the product property. I don't want to get messed up, so I'm meticulous with brackets and parentheses. If you want to distribute the 3x right there, you can. It doesn't really matter. Now we have log base 6 of that mess equals 2. What should we do?
3x times x minus 4 equals 6 squared.
So what are we doing?
We're exponentiating.
I was looking for something else. I like exponentiation. We're definition of a law. Definitionating. So 6 squared equals 3x squared minus 12x. That's your definition of a log. What is 6 squared? 36. Do I bring everybody left or bring everybody to the right? Do I want to be on the 0 on the left, 0 on the right? How do you know? The x squared needs to be positive, and it already is right here. So we want to have 0 on the left, 3x squared minus 12x minus 36. What do we do now? Your favorite F word. Now, before you factor, or you could factor out a 3, but easier than factoring out a 3 is divide out the 3. So we could literally divide both sides, every term by 3. And you're going to get 0 equals x squared minus 4x minus, that's not minus 12. Now, if you do borrowing from the clouds and you don't take the 3 out, it doesn't work at all. Keep that in mind. How does this factor? X plus 2 and x minus 6. So x could either equal, now you have to take those two answers, the -2 and 6, to the original problem and make sure that neither of them will make what you're taking the log of a negative. Log base 6 of 3 times -2, that's going to be log base 6 of -18. Can't be done. So the -2 gets thrown away. 3 times 6 is positive 18. 6 minus 4 is 2. Both positive, all good. So we'll keep the 6. We'll throw away the 2. Your final answer needs to be just x equals 6. Just the way I'm showing it to you. Don't make it a mystery for me. So box in that answer, highlight it, circle it, whatever.
How did you figure out that the -2 is expanded? Just plug it in.
3 times -2,
-6.
6 to what power can give you a negative answer? There's no way.
Yeah.
So we can never take the log of a negative. So that throws that answer away. Now there are times where, like if this was a -3, then x could be a negative.
Right.
And that would be fine. But it's all dependent upon the expressions and what you get down below. Be careful that you don't check it in any of the work below the original, because it'll check there. Both answers will check on the blue down to the bottom. Okay. Try that one. So first thing, again, product property, log of 5x times x minus 1 is 2. What do we do here? You got to be careful on this one. Base is 10. It's common log. So when we press the button, it's going to become 10 squared and 5x squared minus 5x. So don't say, hey, there's no base. There's a base. It's base 10. Set it equal to 0. And again, I would divide out the 5 instead of factoring out the 5. When we factor the trinomial, we're left with x times, or x minus 5 and x plus 4 is equal to 0. So our two potential winners are 5 or -4. Those are the two potential answers. When you plug in the -4, however, you get the log of a negative in the first spot and in the second spot. It's either or both. So the -4 is not going to work. The 5 is going to work. So we extraneous on the -4. And 5 is our solution. Again, When you put in a -4, you'd have the common log of -20. You cannot take the log of a negative. What is in the position of 5x has to be a positive value. Or the x minus 1 has to be a positive value. Too fast, everybody good? You guys are really good at this. We have very high marks in the room on finding the inverse. The rule for finding an inverse, what do? Switch x and y,
And
solve for y. We're in function notation, so what do I do with this f of x? Yeah, right away call that y. Now somebody got confused when I said this first period, so I may be misleading with what I'm saying. All I'm doing right here is getting out of function notation. I have not switched the x's or y's. So once I'm out of function notation, the y becomes x and the x becomes y. Okay, that's the switch. How do I solve for y? What do I do first? Add 13, very good. So x plus 13 equals natural log of y. And how do I solve for not a girl? When you're stuck, definition of a log. What's our base here? E. If it helps you, and I'm not suggesting this in any way, because I don't do this, but if you wanted to write natural log of y equals x plus 13, because that's the way our definition is written, and it's easier for you to make the loop that way, I'm fine with you doing it, but this green line is not necessary. You can make the loop from here and do the same thing. I don't really care. So when you use the definition of a log, this is going to become e to the x plus 13 power is equal to y. Now you do have to switch it back. This is an unacceptable answer. Why is it unacceptable?
Because there's e.
No, e's are, we love e.
Oh, because x isn't.
No, x is good too.
Why?
No. Well, what did you say, sir?
Y has to be f of x.
Y has to be what?
F of x.
Y has to be not f of x, but you're really close. I thought you said it had to be on the other side. You said it.
Yes.
Making Sarah take the fall for it. Y needs to be on the other side so that we can change it back into function notation, but it's not going to be f of x,
Inverse.
f inverse of x. And again, the x plus 13 is just a good habit to put it in parentheses. What I see a lot of people do, they drop that 13, I get e to the x plus 13 like this as an answer. That would be bad. So if you put the x plus 13 in parentheses up in the power spot, you're good to go. How do you get out of jail? You use the definition of a log. Inverses. Switch x and y, solve for y. Try this one. Same drill. All right, let's take a look. So we switched to y first. And then switch your x's and y's. You don't have to reverse here. You can go right to definition of a log. 8 to what power? X is equal to y minus 13. If you solve for y, what do? Add 13. Be careful, it doesn't get added to the x, it gets added to the side. So f inverse of x is going to equal 8 to the power of x plus 13. The 13 is not part of the power. So that's what we're looking for the inverse. Okay? Question on that? Very similar problems. On the left, no work. Log base 7 of 49, 2. No work for that. Definition of a log. Do it in your head. Not a chance are you doing the one on the right in your head. Okay, there's multiple steps to this. And it's not that, oh, I memorized it. Bull. You went through a process in your head, means I want to see what you're doing. So set it equal to z and use the definition of a log. How can I rewrite the 49? 7 squared. How can you rewrite the 1 over 7?
7 to the negative 1 power.
7, yeah, push it up. Power becomes a negative. Now we have the same base. That's what we want. How do I get rid of parentheses on the left?
Multiply.
The 2 and the z. What's the logical conclusion here?
Z equals negative.
So what does z have to equal?
Negative 1
What if I circle that as my answer? How come?
Because we added z, so we have to take away z.
We added the z, so our answer needs to just be negative 1/2. We're evaluating.
So
It's not an equation. We made it an equation to make it easy to solve. But doing that in your head is not what I'm interested in. A little bit of review. Compound interest. What's the formula for compound interest? T times n, or n times t, either way, whichever way you like. What does n represent? The number of compounds in a year. So in question 5, what's n? 365. We're looking for a to equal 9,900. 1 plus 0.0775 divided by 365 to the 365 times 5 power. Izzy is depositing $9,900. 7.75% for 5 years. Would you expect her to have more or less than $20,000 at the end of this investment? More? Her interest rate is 7.75. What's 72 divided by 7.75? Is that it? 9 in a little bit. So that means what? 72 divided by the interest rate tells you what? To double your money. So at 7.75%, it's going to take over 9 years to double your money, more or less. We're doing 5 years. Would you expect to see more or less than double your money? Less. 7.75%, 9 years to double. We're only going 5. It shouldn't be anywhere near double. Double 9,900 is almost 20,000. We will expect to see something significantly less. You need to be able to put this in your calculator and get that number. You need to be able to put this in your calculator. You should be able to do it in one shot and get the correct answer. So 14,000, then what? 0.00. You've got to show the two zeros to show you rounded. At that point, there were no cents. See if you can do the same thing monthly. What changes when we go monthly here? Just the N, just the 365. So how much money would you have if you compounded monthly? 14,567.44.
What does it mean for compound interest? Like,
Compounded means you get interest on your interest. So at the end of January, if you went in and said, how much money do I have? You'd have interest that you earned 1/12 of a year's worth of interest.
right.
That goes in your pile now. Your pile is now bigger, right?
Yeah.
Going February, you get interest on your original investment, $9,900, plus the little pile of money that they added, you got interest on that. Now you have a bigger pile of money. Bigger pile added to the 9,900 gets more interest, and so forth and so on. And if you take that interest and figure it out daily, monthly, whatever, they recalculate your total value at the end of each growth period.
That makes sense.
Okay? And then if you go to continuously, what formula do you use for continuous? Shampoo formula. So A equals P times E to the RT power. See if you can figure out how much your investment is worth using the shampoo formula 0775. Make sure you use your parentheses correctly and see if we're all getting the same final amount. It should be close. It's not going to be that much different. Five. And how many cents? 6. It's down to the cent that I want answers, not in a ballpark. Okay, if you want to just be close, go play horseshoes. We're looking for value down to the cent. Down to the cents. Is anyone having trouble getting the 14,585.60? What are you getting? All right. So last thing I want to point out, just to remind you, what kind of a function is this? One word. Exponential. What's the graph look like?
Exponential growth.
Right. What does the graph look
It looks like this.
Yeah, it's a takeoff. This one, because of the 1/4, is actually going to be a landing, but that's only because of the 1/4. What kind of a function is this?
It's exponential decay.
No,
It's
I just
exponential
want
growth.
one word. Exponential. The variable's in the power. It's exponential. This is a takeoff. Okay? What is this formula for?
Word problems.
One word.
Growth.
Growth. What's this for?
K.
What's this for?
Compound.
Compounded, where you can count the number of compounding periods. And what's this for?
Continuous.
Compound.
Compoundness.
Okay, so here's the 4 that you need, already in our notes. This is your assignment.
I'm so excited.